The second lecture on exponents covers the next three rules for exponent properties. And the quotient rule, quotient means division, so we're looking at x to the cubed over x. So we're going to discover that property through expansion. X cubed means I have three x's being multiplied in my numerator and one single x in the denominator. If you remember about the fraction 5 over 5, we said that was equivalent to 1. So when a number in the numerator matches the same number in the denominator of a fraction, it's equal to a whole. So when I look at this problem, number 1 for quotient rule, I'm going to section off these two x's and leave the remaining 2. So what happens is these two cancel and reduce to a 1, so I'm left with just simply x squared. Now that x squared is in the numerator. If I'd like, I could put a 1 underneath, or I can just write it as x squared. So through expansion, we're going to try to come up with this quotient rule for exponents. X to the 7th is equivalent to 7x's being multiplied in the numerator. X to the 4th, 4x's in the denominator. Noticing that each of these fractions simplify down to 1, I'm left with x times x times x, which is x to the 3rd in the numerator. And in the last problem, number 3, I'm going to go ahead and look at the 3 separate from the 12, because that's a simple fraction that we need to reduce. And then I'm going to keep my x's and group them. And then my y's, and I have y to the 5th in the numerator and a single y in the denominator. Noting the cancellation because they're equal to 1, and taking note of this fraction 3/12. 3/12 is equivalent to the fraction 1/4. I have 2x's in the denominator, x squared, and I have 4x's being multiplied in the numerator, or y to the 4th. So we're going to only look at the exponents. We're going to leave 3/12 as we've normally done, just a fraction. When I look at these exponents, what am I doing every time? I am subtracting. Three minus 1 is 2. 7 minus 4 is 3. 1 minus 3, 1 minus 3 is a negative 2, and we'll be doing that rule here coming up next. But if we don't want to even worry about that negative, I say I have 1x in the numerator, 3 in the denominator. They cancel, leaving me 2 in the denominator. Notice the 2 stayed below. And then when I take 5 minus this power, or exponent of 1, I get 4. So negative exponents then are going to be a little bit different. Negative exponents are going to come from the property above, the quotient property, because we're subtracting. But when I subtract and the numerator is smaller than the exponent in the denominator, just through expansion, we can see what's going to happen once I start making those equivalencies of 1. They all cancel out and give me 1. So I have 1 remaining in the numerator and x squared in the denominator. If I was to go back and use my quotient property that we discovered above, if I had x to the exponent of 3 minus 5, well, 3 minus 5 is negative 2. This negative on the exponent positions it in the denominator. So what I like to say about negative exponents, they're going to change my location. Meaning that my numerator, if it has a negative exponent, it's going to drop down to the denominator. And likewise, if my denominator is negative, it's going to move up to my numerator. So let's take a look here. X to the negative fifth power. If we look at what happened above, that just means that it needs to drop below. There's still a 1 up there because there's always a 1 in front, even though we sometimes don't write it. X to the fifth times x to the third gives me x to the eighth. We can get 8 through expansion or remembering our properties from the earlier lecture. 5 plus 3 is 8. In the second problem, the negative exponent's in the denominator. So it just tells me to change its position, keeping the single x, moving the x cubed to the numerator, leaves me x to the power of 4. In the last problem, I have a couple things to move. Looks like this x to the negative 1 needs to come to the numerator and be with the x cubed. The y to the negative fifth needs to drop to the denominator, and notice it's no longer negative when they change position. And simplifying this, I have 1 and 3 more x's being multiplied, tells me I have 4 being multiplied. 5 y's being multiplied times another y tells me I have y to the sixth being multiplied. And the last property of exponents is called the power of 0. And again, we'll kind of investigate here and try to come up with the rule. If I have x to the fifth over x to the fifth, and I expand, meaning I have 5 x's in the numerator and I have 5 x's in the denominator, looking at these as fractions, x divided by x, and so forth, all the way down, I get a 1. And we discovered that with fractions earlier. If the numerator and denominator match, you have a whole, or 1. If I go back and look at the quotient property that we used earlier, it says you keep the base and subtract the exponents. Well, what is 5 minus 5? Well, it's 0. So I've just kind of held up this equality sign, and I said 1 then is going to be equal to x to the 0 power. 5 minus 5 is x to the 0 power. So therefore, anything to the 0 power equals 1. 5 to the 0 power is simply 1. Y to the 0 power is also 1. 4x to the 0 power. Notice the parentheses, the 0 power is both on the number 4 and the variable x. That is also equal to 1. In this problem, only the x has the power of 0, so that's going to change into a 1. Nothing else changes here because of where my grouping symbols were in question 3 versus in number 4. There are no grouping symbols, so the exponent of 0 is only on the x. Simplifying, I get 7 times 1 times y to the fourth, which is 7y to the fourth.